All right, welcome everybody. Thank you so much for joining today for Demystifying Rainscreen Systems utilizing metal wall panels. We've got the team from ATAS International here today. We've got Jason, he's going to be presenting today's course. And then David is also here on standby for helping out with answering any questions toward the end of today's webinar. We're going to give a quick little introduction in a moment from my colleague Helen. So Helen and I are from Acelab. We're helping out with hosting today's event. Helen's going to give everyone a quick little tour of how to find ATAS on Acelab, get in touch with them after today's webinar in case you have any follow-up questions or want to connect about a project, and give you a quick little guide for using some of Acelab's tools, which everyone who signed up for today's webinar has a free Acelab account made for them. So be sure to check that out. And you can also book a meeting with Helen if you're interested in learning more. So I'll pass it off to Helen in a moment. Just a few housekeeping items for me. This is an AIA-approved course. We did ask for AIA numbers upon registration. I will also send over a form in the chat momentarily, so you can submit it there as well, just in case you're worried we didn't get it when you signed up. Other than that, just want to encourage folks to please submit questions to the Q&A throughout today's webinar. We'll have some time to get to those after the presentation. And if we don't get to your question, we'll have a record of it if you submit it to us there, so you can be followed up with after today's event. All right, that's it for me. Helen, feel free to take it away. Helen's going to give a quick little intro, then we'll get started with today's AIA approved course.
Cool. Hi, everyone. Welcome. It's nice to meet you. My name is Helen, as both mentioned, and I'm going to take you through a quick little tour here of Acelab. So a couple things about Acelab. I'm not going to take you through all the things, but highlight some options that y'all can do within. So one thing that a lot of folks don't know is that you can create projects in Acelab and invite your project team in. You can also do this. Maybe you want to set up a firm library where you just store all the frequently used products that you use. I also want to focus here on this little live chat option. So I'm going to jump into show you this page here. When you live chat, which is available for all of y'all that have signed up with a free account, essentially myself and another colleague will take your request and we go and work with some of the folks you see here. It's a really advanced team, and we put together some recommendations for you, as well as a little video from our Director of Material Research, Andre. So I'll just kind of click in. This is an example. Somebody was under the gun. They needed to hit a certain solar heat gain coefficient, aluminum windows, wrote into the live chat. Our team was able to provide, again, this little video, and then we're able to put together a list for them of products that meet those requirements, including additional information about the glazing. I'll just scroll on down. This is what a comparison looks like in Acelab. So whenever you save a product, and you have a few of them, we create these short lists here so you can see all this information. I'll keep scrolling on down. We also make performance graphs for you, again, comparing these items side by side. So this is some of the stuff you can do in Acelab. I'm going to end up today talking about what you're going to see when we finish up. So if you want to get in touch with these lovely folks, you can type in their name here at the top in your search bar, select their page, and then here you'll be able to connect directly with them. That'll start a conversation within Acelab. You'll also be able to learn a bit more about them and also see all of their products across the categories that we have. One last thing for y'all, when you're finishing up today, you fill in your poll, you're going to receive communication from myself or my colleague, Evelyn, and we're going to start a conversation for you on your behalf with these folks who can then follow up with you on the product literature, samples, things of that nature. You'll see that, you'll get an email, and you can also respond via email now. It's a new feature we just released to get the information y'all need to make your projects have an awesome outcome. I will pass it on back. Thank y'all. Appreciate it.
Thank you so much, Helen. I just launched a quick poll, so if anyone wants to sign up for a quick meeting with Helen, feel free to say yes to that poll. She can give you a further tour about using Acelab and help you to, set up your projects and get your account set up. All right, without further ado, Jason, whenever you're ready, I'd love to hand it over to you to get started with today's course.
All right, thank you, Beth. All right, hello, everybody. We are going to get started today on our presentation. Just a little bit about me and the company real quick before we kick off. I am the Architectural Business Development Manager with ATAS. Been with the company about 4 years now. And we're going to be covering demystifying Rainscreen concepts. I'll try and make this as interesting and lighthearted as possible. I was a practicing architect for a handful of years, so I understand where you are sitting on the other end of the screen here. So we'll try and keep it moving, keep it brisk. If you do have any questions, as Bo mentioned at the onset, We do have Dave Lytle on the call as well today, who is also with ATAS, and he'll be monitoring the chat. If you do have any questions, we'll try and get to those there. If not, we'll have a little time at the end with the presentation. So with that being said, ATAS International is a 60-plus-year-old independently owned manufacturer started in Rochester, New York. We're currently based out of Allentown, PA. We have facilities in Mesa, Arizona, University Park, Illinois, the Chicagoland area. And then we also have a coil coating facility in Pennsylvania as well. We have a wide variety of manufacturing capabilities, metal roofing, standing seam, batten seam, shingles, a whole portfolio of metal wall panels, anything from 24 gauge all the way up to 0.1 aluminum plates. We do perforated aluminum, custom tapered and curved panels for roofing and walls, also custom profiles on the walls, metal column covers, insulated metal wall panels, which we'll be touching on a little bit in today's presentation as well. Interiors, ceiling soffits, acoustically rated profiles as well, perimeter edge metal solutions, a variety of architectural accents and accessories, including secondary framing, snow retention, solar racking, so on and so forth. So with that portion of this being over, here's a review of some of this services offered on our website with spec assistance, submittal builders, BIM modeling, so on and so forth. But certainly feel free to reach out to us through Acelab on the platform here with any project specific or general inquiries, or you can just reach out to us directly as well. So now we will start the AIA portion of the presentation. We're going to be covering Rainscreen concepts using metal wall panels. So a Rainscreen, as most of you are probably well aware, can be out of any number of different skins on the exterior. So we're going to be focusing primarily today on metal wall panels and what that means for a Rainscreen design for you, though. So we're going to help you understand the various types of Rainscreen wall systems. We're going to identify the importance of the nature of that air and water resistance barriers in there and how to design that properly. Discover and define the importance of integrating continuous insulation, which I know is a struggle in the detailing world, and then simplifying your energy efficiency with Rainscreens using insulated metal wall panels. So Rainscreen, is a fairly overused term in the industry. Essentially, is a two-stage method of weatherproofing your building. It must provide that separation between the conditioned space and the exterior environment, provide strength, rigidity, aesthetics, so on and so forth. So it needs to control heat, air, moisture flow, rain, water, wind-driven rain penetration, vapor, UV, noise, vibration. Typically has to be fire rated as well. Needs to be durable. Of course, it must always be economical and provide a certain aesthetic value to it as well. So with that, we'll get into the primary types of wall assemblies, starting with the mass wall, one of your oldest styles of wall there, just a thermal mass wall. Then you have face sealed walls, so think of an EFIS type of system where you're sealing up your insulation on the exterior of the building. Then you get into a drainage plane, which is fairly similar to what we'll be talking about for the most part with the Rainscreens utilizing metal wall panels, just a small drainage plane at the back face. Drainage cavities, getting that system a little bit more robust. This is for more of those porous types of Rainscreens, say masonry or something along those lines. And then we have the sort of Cadillac version of it, if you will, the pressure equalized Rainscreens. And we will talk about that in more detail a little later on in the presentation as well. So Rainscreen cladding, just a brief history. I'm sure a lot of you are very familiar with this, but it's been around essentially as long as building construction has been in place. It's applied so the water vapor coming from within can automatically be removed by ventilation. So this is meant to be not just something to allow for the exterior environment, but also the interior environment, moisture elements to weep at or ventilate out of the building envelope for optimal building health. It's a concept that has evolved a little bit over time, but the primary components of your wall assembly break down as such. You'll have your building structure, be it wood framing, metal studs, what have you, your air or your weather resistance barrier, your continuous insulation, then an airspace, and then your exterior cladding. So the airspace will depend a lot on what that cladding element is. The more porous, the bigger the airspace cavity has to be. In the drainage plane type of wall system, you have essentially two different categories. You have ventilated and vented. I know it's a little bit convoluted to call them something so similar, so apologies. But ventilated is one with vented openings at the top and bottom. So think the longer word is the better or superior option to the two. The vented only allows for the air to vent at the bottom and create a drainage plane out with minimal air circulation throughout the wall assembly there. So vented systems allow for that drainage of the moisture with minimal air movement. Ventilated systems allow for increased air movement, which may increase the drying rates, promoting optimal building health again. The quicker and more efficiently you get the moisture out of the building envelope, the better off the components will be long term. Ventilated and vented systems can promote drying caused by weather. In different areas of the country, if you're south dealing with higher humidity, you'll treat it a little bit differently, but for the most part, this previous slide shows the standard arrangement of the different products in the system. So a lot of different traditional choices. You have bricks, masonry, things of that nature, and now in the functional, the drying wood construction materials covered by a vinyl or a metal cladding or something like that. Drying rates are dependent on a number of variables, and in that you've got to think about what the framing is versus what the cladding is. When you have wood framing and metal cladding, typically your wood's going to dry out and contract versus your metal being heated up and wanting to expand. So there are different issues that we'll talk about in terms of how you not just design your wall section in a vacuum, but how you handle the floor-to-floor transitions and things of that as well. It's up to you as designers how you dial this and how we detail it, but we're here to help support you in that process and making sure you get the desired outcome that resembles as closely as possible to your design vision. Air spaces can eliminate that capillary flow action as well. So what capillary flow is when a bit of moisture gets into a panel lap seam, the capillary action will pull that moisture back through into the airspace. So the bigger the airspace, the less likely that is to occur. A lot of panels do have an anti-siphoning capillary cavity to further reduce that from happening. That's mostly in what we call the exposed fastener world and not the concealed fastener side of things, which a lot of Rainscreens are these days on the concealed fastener side. So having that airspace in there is very important to the overall design of the Rainscreen assembly. So the drainage of the moisture within the cavity is also important. So water will get through. It is not a weather-tight system. That needs to be understood. So this is your first line of defense. It's your primary line of defense against moisture coming in. But there needs to be that drainage cavity to allow that water to either ventilate out the top as vapor or drain out as liquid through the bottom. Ventilated and vented wall assemblies help to minimize the rot and mold. Like I said, it's here to promote optimal building health and keeping your building components dry and functioning as optimally as possible. Metal is one of the preferred options, especially nowadays, for a couple of different reasons. First, it has no absorption values. It's non-porous, so water only is getting through a metal wall panel via the lap seams between the panels. Beyond that, because it's non-porous, the cavity behind can be much skinnier or thinner than a lot of other products. So as I mentioned earlier, the more porosity of the Rainscreen system, the more airspace that is needed behind the rain screen. So a typical brick rain screen wall will have about a 3.5-inch air cavity behind it, whereas a rain screen made out of metal wall panels can get by with as little as 3/8 of an inch between. So now we'll get into a little bit more about the detailed construction of the assemblies. So here you have a typical wall section showing you a vented rain screen system. This is going over open framing. You've got panels in a horizontal orientation. So you've got vertical subskirts behind it, allowing that airflow up and down throughout the wall assembly. You have at the bottom a perforated J channel. A lot of times this component is left out. It's really in there for one reason, which is to minimize any infestation issues. So it might seem like a unnecessary component, but it is in there for a very good reason. This wall assembly here has that airspace behind. It allows for the moisture to condensate and then pull out through the bottom using the weeps in the perforated J channel at the bottom of the product or the wall assembly there. Ventilated takes that concept and adds to it by allowing the moisture to vent out at the top. So you are allowing the liquid moisture to weep out at the bottom, but with a rain screen made out of metal specifically, that airspace gets very hot very quickly. So think a summer shower moves through, and then you have the sun come out and that moisture is in there and getting heated up very rapidly. That creates a vapor condition that, as we all know, warm air rises, vapor rises, and if you don't have this ventilated airspace at the top for that moisture to weep out as vapor, it'll take longer for the building to dry out and could contribute to the long-term health of the building. So normally what you do is you pull back your blocking. You'll have to double up your coping cap blocking and create that space, pull your coping a slightly, little bit off of the rain screen assembly to have that airspace, perforated Z at the top, again, for the moisture to weep out. And then you have what is considered an optimal design for your rain screen assembly here. This is an image here of the material being installed on a rain screen. We have the detail blow up there because it is a fairly small component and really hard to see from a distance. But in the inset there, you can see that ventilated perforated channel at the base. This assembly, it also went at the top of the wall there to help create that fully ventilated rain screen assembly. So the components within a wall assembly, we touched on this early on, but again, building structure, brick, block, if it's masonry, wood, or metal framing is more often than not what we're dealing with. It may incorporate a facing of the building structure, such as plywood or exterior gypsum as well. Here you have a metal framed building, metal structural steel, metal stud framing, very standard application for your rain screens to be attached to. After your structure and sheathing, you'll have your air barrier or your weather resistance barrier. This is a great illustration of where we are in this space currently. So your weather resistance barrier is there to essentially reject that last bit of moisture that does get through and is not able to properly ventilate out of the rain screen airspace. So it will reject moisture coming through from the exterior, but it is now more often than not at least semi-permeable, if not fully permeable, allowing interior vapor to escape out. So again, we're pulling the moisture out of the building as well. So we need to make sure that we are allowing for that moisture to escape in the rain screen design. Your insulation or continuous insulation does what it's intended to do, reducing that heat transfer from into and out of the building. Water resistant materials are required in this because it is an open air space that is susceptible to the elements. And again, having that drying time reduced is very important to the long-term health of your insulation behind the Rainscreen assembly. It also helps to minimize your chances of condensation and thermal bridging. You do see screw fasteners going through this into structure. That is required more often than not, but there are a number of tricks that we'll talk about in terms of thermal isolation a little later on in the presentation. So a lot of the standard types of insulation you'll see nowadays, the blue board, the polyiso, the foil lined as well. More and more you're seeing spray foam applications out there in the space, the construction industry as well. Your Sims panels where you have laminated exterior grade plywood with self-adhesive sheathing or WRBs, sorry, on top of that. And then the Cadillac of the industry, if you will, are insulated metal wall panels. Those can be fire rated with mineral wool cores or standard with polyiso infill. Next up in the wall assembly is your airspace. And again, this is one of those critical elements that we need to make sure that we incorporate into the Rainscreen design for proper building health. That ventilation cavity and drainage plane that allows that airflow up and down. In pressure equalized Rainscreens, it helps facilitate the rapid pressure equalization of the building. That is for typically projects that are somewhere between 12 and 14, maybe 16 stories or taller. It doesn't apply to a lot of buildings, but might be something that you're looking at on some projects, depending on what type of work and where you are in the country. So in terms of wall construction, there are a couple of variations to talk about with your panel orientation. Normally, we're talking about panels either being installed horizontally, like we see here, or having the panels being installed vertically. Where this comes into play more than anywhere else is with the airspace and the subframing required. So here you can see the panels are oriented horizontally. That is the strength of the panel going horizontally. It doesn't have a lot of strength laterally. No matter what profile you're talking about, they're always much weaker in that cross section than they are in the length direction. So here you've got continuous supports up and down the building running vertically, which is great, allows for that airflow up and down in those cavities. We're not so concerned about horizontal cross ventilation. As long as the vapor can go up and the moisture can go down, that's what we're mostly concerned about in this configuration. So the exterior cladding, again, being oriented horizontally, there to manage and control the prevention of water infiltration, wind and other environmental loads, and UV protection so that your continuous insulation doesn't deteriorate over time. Here you can see another application image using horizontal panels. This one is a fun one, same profile, just mixing and matching and playing color blocking with this one to create some interest in the facade. Now we get into vertical panel orientation. Nothing different really about this conceptually, but what we're going to have here is that we're going to maintain the vertical supports at the continuous insulation edge. And then we'll have to introduce a secondary layer of supports to support the panels in the strength direction. This is in part because you don't want to have just horizontal supports right up against your insulation there as your only member of framing, because that will really restrict the ability for air and vapor to move around throughout that cavity. I have seen it done where you will go with that horizontal member up against the insulation and they try and perforate the channels so that air and vapor can, or water and vapor can move throughout the airspace, but it really doesn't function as well as it should. And again, you're creating a shelf where moisture can fit and create some potential environmental issues with your wall assembly if you try and put that right up against your insulation. Here's an application showing vertical panel installations. And again, your airspace gets a little bit bigger because of the doubled framing, but it's all in the name of optimal building health and making sure you have the best functioning Rainscreen system possible. Here's another installation showing it vertically installed. This is the same profile, just using a bunch of different panel profiles within that family, and then having some perforated panels in there for added texture. It's not different colors. Those are just perforated sections that you see there in the darker grays. One other thing that you'll note here is there's a lot of horizontal breaks. This is in part to do with the wood framing topic that we talked about earlier, where wood will dry out and contract, and especially once the building's fully loaded, it'll start to shrink a little bit more, whereas your panels will continue to be exposed to the elements and expand and contract. So making sure that you have break lines at your floor to floors, or something similar like with this at the window lines, breaking it up even more frequently, really helps to contribute to the overall design of your rain screen, being a really solid part of the design. So in the wall construction, again, in the horizontal panel orientation, you've got the structure, the sheathing, the vapor barrier, your continuous insulation, your subframing for your airspace, and then the exterior metal rain screen, variety of different attachments, mechanisms here. So usually you're just attaching the rain screen to the girt, and then the girt through the insulation into the building structure. Here's another nice installation featuring a concealed fastener system. Here they even went to the extreme of wrapping it around the balcony base as a fascia element as well. Really a well-executed design and rain screen there. Here you have it more as an accent band, still a rain screen in its purest concept, but with ribbon windows. They had ribbon elements of the rain screen in there also. So we've talked about the two, the drained and back-vented primarily up until this point. The second type, which I've alluded to a couple different parts of the presentation, is the pressure equalized rain screen. And now we're going to talk about what the two are, when they're appropriate, and what goes into each of them a little bit more in detail. So drained and back vented, which is what we've been primarily talking about up to this point, series of sheets or panels, i.e. cladding attached to vertical supports to comprise that exterior layer. Joints in the sheets may be opened or sealed. Typically they're open, not sealed. But there are designs in the laps to control that water penetration as best as possible. These are designed, like I said earlier, to minimize, not prevent water penetration. So here you have an example of a drained and back vented panel using a metal wall panel. The wetting of the interior leaf of the structure is permitted. It can occur. These are not weather-tight systems like I mentioned earlier. It's there primarily to prevent as much moisture from getting in as possible, thus the airspace to make sure that that gets dried out as best as possible. With the cavity depth, like I said, the porosity of the cladding is the driver. With metal, 3/8 of an inch is allowable. Preferable is somewhere around 3/4 of an inch. But as you have a more porous material, let's say a terracotta tile or masonry, you're going to have to up that to 3, 4, maybe even 5 inches. Drained and back vented assemblies do have an AMA test. It is a voluntary test. I will caution you that no manufacturer has this testing because this is for the wall assembly. So you have insulation, vapor barriers, subgirts, framing, sheathing, and the rain screen cladding all as a part of this. So this is usually a one-off, one-of-one test that you have to do. But it is there to test for water penetrations. It's a W1 through a W11, and then a V1 through V11 for the ventilation established within the rain screen assembly. And again, just as a refresher, here is your typical rain screen with your interior finish, your stud wall, your sheathing, vapor barrier, continuous insulation, subframing, and then your rain screen assembly. So for metal cladding applications, it can run the gamut, anything from residential through high-end commercial and institutional. It's everywhere in the construction industry. Pressure equalized is the same, but very, very different, if that makes any sense. So pressure equalized is primarily in high-rise commercial construction. Like I said earlier, somewhere around 12 to 16 stories is going to be when this comes into play. I've worked on some towers, if you want to call them that are in the 12 to 14 story range and have been a standard drained and back vented assembly, although they did go with a higher gauge cladding just for the wind loads applied to it. Now, typically, a pressure equalized system is going to be very design intensive compared to a drained and back vented assembly. These must be designed with static and dynamic pressure equalizations, limits water passing through the outer cladding by this pressure equalization. So essentially, it's looking at a wind tunnel test and figuring out how the air will move around the building and how that wind tunnel test informs the design of the paneling system and the joinery so that the rainwater that does penetrate can get out of the wall assembly as efficiently as possible. You have non-compartmentalized ventilation cavities that cannot be classified as pressure equalized, as large volumes of water may penetrate the cavity as a result. Compartmentalization is essential for wind pressure across the face. It's not typically uniform, thus the static and dynamic pressure testing required. Again, what I cannot stress enough is that this is a highly engineered system. It's essentially developed project specific. So when that need does arise, you'll usually need to hire on a consultant to help develop that. A lot of manufacturers don't have the in-house expertise to do this. So a third-party engineering company would usually be recommended as well. There is an AMA test for pressure equalized rain screens as well. AMA 50821, another voluntary test here. This one I would say is definitely more recommended than the drained and back vented though. I just sat through a large presentation on the new Indiana University health hospital project in Indianapolis, Indiana. And they had a pressure equalized rain screen on that building. It was made out of limestone cladding and curtain wall, unitized curtain wall. They spent $1.2 million on their testing, but they got to a point where they were very happy with the building envelope design and specifically with the rainwater issues that they were afraid of. So it was a lot of money, but this is also a $200 billion, a $2.1 billion project, so a relatively small part of the overall budget. This is a pass or fail standard, however, unlike the drained and back vented, where it's graded 1 through 11. This is either it passes or it doesn't. Passing does still allow for some water to weep through, so just bear that in mind. At the IU Health project that I referenced, they got a pass, but they still felt that the amount of moisture getting through was unacceptable, so they did it a second time and did a lot of additional testing and tweaking and customizing of their details. Here you can see a typical detail. Again, the joinery is a little bit different. Normally we're just having panels and a drained and back vented lap together and screwed through. Here you can see it's more of a plate style system, countersunk bores to attach to extruded frames. And this is how a pressure equalized system functions typically. But like I said, everything's pretty much project specific. So I won't say that this is a standard, but this is a fairly emblematic detail of what you might see in a pressure equalized rain screen system. So the differences between these two systems, like I said, they're both functioning in the same method to protect the building from that wind-driven rain, UV, so on and so forth. The cladding and joinery in the pressure equalized system is altered to create extensions of the face, giving it a little more depth and profile and character. It's highly engineered on the pressure equalized side versus fairly straightforward standard ASTM testing applies on the drained and backvented, and you can get away with a lot of standard details in drained and backvented versus pressure equalized. The different tests, again, the drained and backvented AMA 50914, and then the pressure equalized 50821. Common test procedures identified within the specifications are typically ASTM E283 and E331 for water and air infiltration on these systems. Here you can see the dynamic water penetration, terribly sophisticated, essentially getting a couple garden hoses up against a couple of fans and shooting the water through the fans at a high rate of speed at your rain screen, and then measuring the water penetration from the back face. So with that being covered, now we'll get into more wall cladding applications and what that can look like in terms of your assembly. So what we've talked about up to this point is pretty much everything being over open framing to create that drainage cavity. There are metal wall panels out there that you might specify that are non-structural and can't go over open framing. And how do you handle that? The best way to handle that is through something like you see here, a drainage mat. Inca mat or one of those other types of brands is what we would recommend. Here you can see you screw through that into the substrate directly. This is going to give you that 3/8 inch drainage plane behind the metal wall panels. And the only real challenge here is making sure that the installing contractor doesn't over torque and then pucker or pull in your metal wall panels at those connection points. Another option is above sheathing ventilation shims. This is primarily used in the metal roofing world, actually, but it is finding a place in the metal wall panel space as well. You can stack these plastic shims. You get 3/8 inch, 3/4 inch, up to 1 1/8 inch. It does have to go over a structural panel. It also should probably only be installed with structural concealed fastener panels. In the exposed fastener world, we're dealing with panels that are 3 foot wide, and as you're trying to line these up and get these to hit your valleys and your connection points on a 3 foot wide panel can be quite challenging. So we typically recommend keeping it with just concealed fasteners. But it does have to be on a structural panel. Otherwise, you're just going to have them so close together, you might as well go with continuous supports there. Shop form hat sections, you can see a variety of these. There's a couple standard profiles out there, but you can see here in the detail blow up, there are all sorts of shapes and sizes to these as well, depending on the application. There are self-adhered shims as well. So this comes more into play for a vertical panel installation where maybe you don't have the space, or you're looking at budget alternatives to a vertical and then a horizontal subgirt. These adhered shims can provide that breathability, pulling the horizontal supports off the face of the sheathing or the continuous insulation, and allowing that air movement that that's required back there. Engineered systems. Here you've got some different things that we can talk about in terms of engineered systems. So these are standoffs that either support engineered subframing or can be a part of the thermal isolation with your Rainscreen wall assembly. Night wall, I know we're supposed to be non-proprietary, but I don't represent them, so I think I can talk about them okay. They're probably the best recommended thermal isolation and structural standoff for fire-rated wall assemblies. Smart CI is another great one. It's a pultruded fiberglass extrusion that goes into the rigid board insulation, as you can see here. Because of the pultruded fiberglass, it has the pull-out strength needed, so you can attach directly to that exterior face with your subgirts or your metal wall panel systems, and then you attach on that up leg behind it. The next layer of insulation comes down, covering that screw head, and you have a thermally isolated, non-conductive connection there for your CI. I'm sure everyone on the webinar is pretty familiar with the new ASHRA or newish ASHRA 90.1 standard. But if you're not, it's defined as insulation that is continuous across all structural members without thermal bridges other than fasteners and surface openings. So there is an allowable percentage of thermal bridging allowed to occur, but we're always trying to minimize that as best as possible. And building technology keeps evolving to meet those standards. Here's the ASHRAE zone map for you. So I know we've got people from all over the country. We break it down by essentially 8 different climate zones. One being, very hot and humid, and then 8 being that subarctic, Arctic area up in Alaska. But then we have the marine, mostly hugging the West Coast. Then you have the dry, the mountains and the Western Plains. And then you have the moist, essentially from the central US all the way to the East Coast. So where you are kind of informs some of how you have to handle your CI and specifically how you handle your vapor barrier. Somewhere along the lines of zone, we'll say zone 3, you'll start to flip your weather resistant barrier from interior side of the insulation to exterior side. There, your goal is to keep as much moisture out of your insulation as possible to prevent mold buildup. But with continuous insulation, the devil is in the details, as they say. That conductivity of the material penetrating the insulation is what we really need to look at, and how can we help you design a Rainscreen that minimizes that as best as possible. One way to handle it is with a thermally broken fastener. Thermostop is a great product. It has a thermal break in the fastener head, allows you to just screw straight through the building structure without any real care or concern for those penetrations and the conductivity of them. Standard C channels here, usually they're drilled with a pilot hole on the back face and then a wider driver head on the front face so that the driver head can get in there without an extension and helps the contractor install it more efficiently. Another way to handle your CI is to have your CI be your exterior cladding with an insulated metal wall panel system. This is an all-in-one type of system, potentially, depending on your design and your aesthetic choices. A lot of times we're seeing insulated metal wall panels being used as what's called a barrier backup. Here it's replacing your sheathing, your vapor barrier, and your CI all in one component. You'll have a panel that is defined as A, usually 2 to 4 inches in thickness. You get R7 per inch on an insulated metal wall panel. You'll put in the double tongue and groove assembly 2 beads of non-skidding butyl. That's your vapor seal. And then you have a thermally isolated clip and fastener, and there you have your CI. So with an exterior and interior face, usually 26 and 24 gauge, sometimes 24 and 22 gauge, you have an all-in-one building envelope product here. With that being said, insulated metal wall panels don't offer as much versatility in terms of profiles and in terms of colors. So a lot of times, like I said, you're using it as a barrier backup and then putting a Rainscreen assembly over the top. This detailing essentially mirrors a lot of the other conventional wall assemblies we talked about. Instead of going through insulation and sheathing, you're going through an insulated metal wall panel here. Your air barrier or weather resistance barrier is another key component of this wall assembly. It's there to minimize the condensation through vapor transmission. It's your last and most critical line of defense against water infiltration into your building. Now, there are essentially 3 categories of this: impermeable, semi-permeable, and permeable. The industry as a whole has moved more towards semi-permeable and even permeable to facilitate the ventilation of excess humidity and moisture out of the building and into the environment. So again, we're looking to create more holistically healthy building environments for our occupation today. Weather resistant barriers, building design is dependent on the placement, building use, and geographical location. Like I said, somewhere on that ASHRAE map around zone 3, zone 4, you're going to flip where that is in your wall assembly due to the high degree of humidity present and the higher temperatures in those environments. Weather-resistant barrier manufacturers offer a lot of different options to address very specific needs. I will admit I am by no means an expert. I just know enough to be dangerous here, but we're always happy to recommend some different manufacturers for you in this space. Like I said earlier, you're seeing a lot more of the vapor permeable right now, and what that is greater than 1 perm. So a lot of what you're seeing now is up to 25 or even 50 perms allowable. So it's really kind of changed the way that this part of the industry is moving forward. There's been a lot of advances over the last handful of years. There are some computer modeling softwares out there to help you optimize and design your wall assemblies. Woofy, it's a German, as you can tell from the spelled out name of it, is one of the best ones out there. I've not used it personally, but it will fully model the energy and the condensation and the energy efficiency of your Rainscreen assembly here. Another thing that you have to deal with in Rainscreen design is NFPA 285. It's a standard for fire testing methods. Again, nobody is specific, no assembly that I'm aware of is specifically tested to this, because you're like with the voluntary AMA test for drained and back vented and pressure equalized Rainscreens, you have a variety of different manufacturers in there. The advantage of using a metal Rainscreen system is metal is inherently non-combustible and will not be a part of that problem. Using an insulated metal wall panel can also really help to simplify your life when designing for an NFPA 285. Even if you don't use mineral wool infill, you can get a Class 1A designation on your insulated metal wall panel. Many insulation manufacturers have tested their assemblies as to how they perform in NFPA 285. So again, do your research on those guys. But I would highly recommend considering an insulated metal wall panel there. Your air and water barrier manufacturers also have to have theirs tested for different combustibility as well. And then, several other criteria that come into play: the panel joint size, location, and engineering evaluations. So if you do get a test, this is more or less what it looks like. They shoot fire into through a furnace right into the wall assembly, and if it doesn't catch on fire or combust, it's passed. So again, the assembly overall is pretty much the same. You're just making sure that everything you have in here is fire rated. This is a nice slide that kind of illustrates if you need to adhere to NFPA 285 or not. I know there are usually a lot of questions on this, but essentially, if you have anything that's over 40 stories in height and it's commercial in nature, you essentially have to go with NFPA 285 guidelines. There are some exceptions in there, but this slide kind of covers a lot of that evaluation for you. We can make it available if anyone needs it further down the road. Metal wall cladding applications. Getting into the aesthetics of this now, which I'm sure a lot of you are here for, more than some of the technical stuff we've been discussing. Your metal Rainscreen can be curved. It can have factory formed miters. Crimp curving is pretty common, especially in deeper ribbed profiles, but you can get a lot of profiles stretch formed. Depending on what the profile is, that will affect the radius. But there is stretch forming available as well, where you don't have the crimping in there. Z boxes. A lot of manufacturers offer Z boxes now. This is essentially a shop fabricated metal assembly for your electrical, ventilation, mechanical penetrations in your wall assembly. It comes out looking a lot nicer than the tradesman, usually someone that didn't install the metal wall panel, coming in, cutting a hole, running their piping or electrical through, and then just leaving it for the guy to come back and fix after the fact. These are nice, clean assemblies that mount directly to substrate or solid or open framing, and then allow for that penetration. They can have cover plates or just use the cover plates of the exhaust elements or security cameras or whatever you have. Another Rainscreen assembly that we'll touch on briefly is called a transpired solar collector. This is an interesting concept in terms of rain screens. It is a true rain screen because these wall assemblies are perforated. The wall assemblies are perforated or microlanced to allow the airflow through the panel. So water will inherently get through. The other big difference here is, as we've talked about, your drainage cavity behind the rain screen will be around 3/4 of an inch with metal wall panels. Here it's going to be somewhere between 4 and 8 inches. The idea is that you're creating an air plenum behind with enough air to be drawn into your HVAC system, that you're pulling sufficient preheated air into your HVAC system using the sun's energy. Like I said, metal panels conduct that heat very rapidly, transfers it into that air behind it, and then you pull that air into your HVAC system in the winter months, pulling in superheated air. Usually you're getting at least a 50-degree delta from exterior to intake temperature with that design. So on a 30-degree day, you're pulling in 80-degree air, which is a big advantage and helps reduce wear and tear on your HVAC. Construction criteria, a lot of different scientific principles go into this, especially with the pressure equalized rain screen systems. But you know, at the end of the day, your design should allow for and address construction tolerances in the field. These are things as simple as, you know, the building's just not built square, or the floor to floor isn't stacking neatly, or you know, other issues like I mentioned where the wood framing will dry out and contract versus metal wall panels heating up and expanding. Air and weather resistant barriers, again, you're seeing sometimes now a dual model as well, where you're stretching out essentially where the condensation can occur. So instead of having it up against your metal framing or your building structure in that sheathing element behind, here you're allowing it in the middle space more, and that allows for it to weep out as well. Hidden dangers, like I said, making sure that you have it aligned properly where your weather resistant barrier is in terms of the insulation, very important. Here's an example of probably an architect from somewhere in the northern US designing a project in Lakeland, Florida, where they put the weather barrier on the wrong side of the insulation, and you had a tremendous mold outbreak in your continuous insulation in this building here. Other issues to be aware of. This slide is a couple of them. Saggy, baggy vapor barrier, not acceptable. That is not a good installation of weather barrier back there. The other red flag here is they're using horizontal wood furring strips instead of metal framing and having it running vertically. So this is a double no-no in terms of other inferior issues that you need to be aware of with your rain screens in the installation process. Here is an example of what I was talking about with multi-material tolerances, i.e. wood and metal. These are two examples of wood frame buildings where they tried to span panels or trims over floor to floor, and they got buckling and bursts because the wood contracted and the metal expanded, and the pressures came to a head, and this is the end result. So again, making sure you break panels and trims at floor to floor joints is imperative to having a really good rain screen installation at the end of the day. The coordination of trades is another key area. You are seeing more and more of a consolidation of this, but any rain screen assembly usually has 2 or 3 trades in it at least, maybe more. But between the building structure, the sheathing, the vapor barrier, the CI, and the rain screen, you're usually talking about 2 or 3 different tradesmen out there. And who's going to handle what, making sure it's built as designed and detailed, getting that flashing in there, that comes up back behind the insulation is also very important to this. A lot of times I'll see a project where only the flashing at the base of the rain screen is installed, and that creates just moisture issues at your window head or door head or whatever that termination ends up being. So with that, we have wrapped up. We have a little bit of time for questions and answers here, but I just wanted to touch base with everyone and see if there was any follow-up questions that you might have.
Jason, we have a couple.
Okay.
The first one is from Christian, and it would a ventilated cavity always be preferred over a vented cavity? For example, would a brick veneer wall with vents at top and bottom perform better than one with only weeps at the bottom?
Well, that's a good question. In the metal wall space, I would say it's always preferred to have a ventilated cavity versus a vented cavity. Not so much an expert in the masonry, but I don't see how that could be a bad thing for your masonry rain screen either.
Okay. The next one's from Eula, and it's what is the best way to weatherproof fasteners going through your weather-resistant barrier?
That's a great question. So typically what is recommended is a hex head fastener with an integrated washer head that is self-sealing. So it's going to be a rubberized gasket that will help seal up that penetration there, because yes, it will drill through and it will tear it up, and it will be ever so slightly larger than the screw itself. So that self-sealing integrated washer head is imperative.
Okay. And then from Juan, is there any special consideration for flush mounted building signage over rain screens?
Yeah, so that is something that definitely should be coordinated. Not so much necessarily with the rain screen manufacturer, although it's good for them to be a part of the conversation. But usually there you just need extra blocking behind the rain screen where the signage is going, and that will install and attach through the rain screen into the blocking behind. Rain screens 99.9% of the time are not designed to handle that load. Anything beyond some very small standard residential scale stuff, you need to go with wood blocking behind it.
Okay. One more quick one. How thick can continuous insulation be and still have a solid connection to the underlying structure?
That is a good question. I'm not sure that I know the exact answer to that, but I know that our insulated metal wall panels can go up to 6 inches in depth. So I would say that's probably about it. At R7 per inch, you're getting up over R40. So you've got a fairly robust system at that point. So I think your practical R value caps out before you get into a structural issue.
Okay. And Richard, we can share details offline. We will send that to you directly on the butt joint detail.
Yeah. And then the question on damaged panels, it kind of depends on the panel system itself. You can sometimes, especially it's something where you're going to have to take down a whole wall to get to a damaged piece. There are splice assemblies that can be attached via structural adhesives or rivets, pop rivets. Working with a contractor on one of those types of issues right now. But yeah, outside of that, unfortunately, it's a sequential installation, and to get to the damaged piece, you have to take down everything you installed after that.
Okay, and Jack Smith asked about interior vapor barriers.
Interior vapor barriers. So again, I'm not being a vapor barrier expert, but usually what you're doing there is you're trying to specifically identify where the condensation is going to occur. I don't know that you would really want it on the interior, because that means it's going to happen in the stud wall cavity. And then I'm not sure how you would be able to get that moisture ventilated out. So it's good to have it on, like the exterior side of the framing, and then potentially, like we saw on the one slide, a double layer where it's on the exterior side of the continuous insulation as well. I think that answers your question, but if not, I apologize, and you can shoot us a message and we'll try and make sure we answer it appropriately.
Okay. What was the wall system with the ventilated fan called at the end?
With the ventilated fan.
It was the Inspire.
Yeah, so it's called a transpired solar collector. At ATAS, we brand it as Inspire Wall. We have a whole presentation specifically dedicated to just that system. It gets into the whole mechanical engineering of it as well. But it's a really interesting concept to explore, especially in the world of sustainability. If you're already looking at a metal rain screen and you're looking at ways to make your building as sustainable as possible, it's a really nice add-on, if you will, for LEED credits and sustainability to look at that type of a wall assembly. Typically, it's done with an exposed fastener system, but that is not by any means limited to that. You can use just about any panel profile, and there are different ways to perforate it or micro-lance it to get the open area or CFM that you need for the HVAC side of that system.
Great, and we'll follow up directly with everybody that asks a question, just to make sure that it gets answered properly after the presentation. But thank you very much, Jason and Bo. I'll leave it to you guys.
Yeah.
Awesome.
All right,
Awesome.
Thank you, everyone.
Yeah, thank you everybody so much in the attendance for coming out today. And thank you, Jason and David, for a wonderful presentation and for all your hard work answering all those questions. So I hope everyone has a great rest of their Wednesday.
Our pleasure.
Thank you.
Thank you.